Okay, this is a video for the notes for 11.5, which are going to talk about the volume of a prism and a cylinder. And there's a few words that they give to define. We're just going to hit these as we go. So we'll see them as we work through the notes. Volume of a prism. So a prism is a three-dimensional shape, and in this case it has a base that's expressed with an area of B. And the one we're given in this particular picture appears as though it has a square base, could be a rectangle. The base can be any shape. So the idea is that to compute volume, you take the base. In this case, it would be length times width because we're looking at either a square or a rectangle. And then you multiply by height. And you can notice on this one, or what's kind of different about this one, is they give you two pictures. One that's a right prism, or a 90-degree prism that's standing straight up, and the other that's slanted. And the reason they do that is to highlight kind of one of the big ideas on this is whether your prism is standing perfectly straight upright at 90 degrees or it's slanted, it's going to have the same volume provided that the height up from the ground is the same. And the way I think the best to think about it is think about a stack of papers. Like if you took a stack of printer paper and you stacked it perfectly straight, that's this one. If you then took that stack and slanted it, so each one was just slightly slanted off the one below it, it would still have the same height. It's not going to shrink down, but it'll be at a slant. And the way you would measure the height up from the ground is by measuring it straight up at 90 degrees. And so even though the slanted stack of paper looks different, it's got the same volume. It's got the same amount of stuff that makes it up. And that's what volume is. Volume is the amount of stuff that makes up a three-dimensional shape. A lot like in two dimensions, area is the stuff that's on the inside of a border. That's what's happening here with the volume. So whether you have a straight up and down stack of paper or a slanted stack of paper, you compute the volume the same way, and that computation is actually pretty straightforward. It's base, or the area of the base, so capital B is the area of the base, times height. And height being measured up at 90 degrees from like a tabletop surface or a flat ground type surface. And then they give another example of this, or another picture example on the second page of a cylinder. And the equation is actually exactly the same. It's capital B times H. And then what they do, or you'll notice what they do, is they, instead of a B, they'll write pi r squared. Well, the area of a circle, which is what a cylinder is, it's a three-dimensional object that has a circle for a base. The circle's area is pi r squared. So pi r squared is the area of the base, and then times height. And you'll notice here again, whether it's straight up and down at a 90 degree or a right cylinder, is the same as if you slant it. And again here, with circles, you can think of a stack of quarters. If you took a stack of quarters and stacked them all up, that would be a cylinder. And then if you just slanted that stack of quarters, it would have the same height. It wouldn't shrink. So again, stack of quarters standing straight up, that's this one. And then if we slant it, that's this one. It would still have the exact same amount of stuff making it up. And that idea is whether or not we're standing straight up or we're at a slant, we're going to measure height up from the ground at 90 degrees. And then you compute the volume the same way. So you can have a square, a rectangle, a circle. You can have other shapes too. And we will eventually touch on this, actually probably a second video. We'll talk about similarity. But on this first video, we're just going to look at volume. So finding the volume of a prism. So on this first prism, it's not a square, it's not a rectangle, it's not a circle. They're giving us a triangle, and then they're giving us this prism shape. So to find it, it's always volume equals the area of the base times height. So first off, you got to say, well, what is the base? It's a triangle. Area of a triangle, so to find the area of a triangle, and that's what we're after here. We're after the area of that triangle. So the area of the triangle, or the area of the base, is 1/2 base height. And that can be confusing because I'm using a capital B to be the base of the cylinder. And I'm using a little b to be the base of the triangle. I'm also using H twice. So you have to be really careful with how you're using letters here. In this case, the height, little h, on the triangle is 1.5. The base is 3, and that's a 3 that kind of got obscured in there. and then we have half. So our area of the base, our triangular base, is half times 1.5 times 3, or half times 3 times 1.5. And you can plug that into a calculator, half times 3 times 1.5. And if you do that, half times 3 is 1.5, and 1.5 times 1.5 is 2.25. And so our area of our base is 2.25. And let's verify that. So let's go half, or 0.5, times 3 times 1.5, just to make sure I'm right and I'm not skipping anything. And there's our 2.25. So that's the area of the triangle. And then what we're going to do is say, okay, now we're going to multiply that area of the triangle, which is 2.25, that's our base, times height, which in this case, the height of the overall thing, the overall prism, is a 5. So we have this triangular prism. So then we're going to take our 2.25 and we're going to multiply by 5. So times by 5. And our volume is going to be 11.25. So our volume then is 11.25. And in this case, it would be cubic centimeters. And volume being cubed, area is squared. And if we just have a one-dimensional thing, it's linear. So the side length is considered linear, or centimeters. An area would be centimeters squared, and then a volume is centimeters cubed. Second one, actually a more complex shape going on because it's slanted, and it's got what looks to be a pentagon, so a 5-sided base, but they're giving you the area of the base. You're not having to compute it. So for volume, we're doing base times height. Well, they told you the base is 10. The height measured up at 90 degrees is 4, and the volume then is 40. And here it would be inches cubed. Again, area is in squared, linear, just the line is measured as just inches. And then when we do the dimensions on volume, we get 3 of those. So the area of the base has squared in it, the area of the height has single inches in it. So that means we have 3 sets of inches going on. We have 1, 2, 3 sets of centimeters going on. So you get centimeters cubed, you get inches cubed. And that's it. That's how you would do, if they give you the area of a base, how you would do the volume. Number 3, we're again finding volume, and here it's a right cylinder. So it's perfectly up and down, which means the height is measured through the middle, and they're giving us a radius. So if we want the volume of a cylinder, we need base height. And to find the area of the base, we're going to do pi r squared. Well, r is 2.5, so we'll do pi times 2.5 squared. Let's just jump into the calculator and do that. So what would that be? It'd be pi, that's this key, times 2.5 squared, and hit enter. And that's going to be a big number. I'm just going to leave it in the calculator, but 19.6. So volume would be that 19.6 number times height, which is 7. And again, my recommendation, leave it in the calculator, just hit times 7, and it'll take that whole answer, multiply it by 7. So we get 137 point, whole bunch of 4s, and technically actually this 6 would round this 4 up to a 5, that would then round this 4 up to a 5, and that would then round this 4 up to a 5, so it's 137.5, assuming they want us to go to the nearest tenth, which they don't say, but I'm going to assume that to be the case. So 137.5 inches cubed. The next one, really similar problem, except it's slanted, but that doesn't really change what we're going to do. So we're going to say, okay, the base is a circle, so pi r squared. Well, 2 squared I know, that's just 4, so base is 4 pi. So I can take and plug in 4 pi, and I'll do that in a minute. And then our volume is going to be that area of the base times height, which in this case is 11. So let's see. Let's go to my calculator. I'll do 4 pi and hit enter. And that's 12.56, so we'll call it 12.6. So volume is 12.6 times 11. And again, my recommendation, just leave it in the calculator. We'll pop over here and do times 11. Hit enter, and we get 138.2. So volume is 138.2, and this is going to be centimeters cubed. Okay, and that's just computing volumes, and they give us a couple different shapes there. They're going to also turn this equation around and ask us to find different pieces of it. As a for instance, they're telling us that the height of a cylinder with a base radius of 8 inches and a volume of 2010 cubic inches. So they want us to find the indicated measure. So find the height of a cylinder. with a base radius? Well, let's see. All I need to do is look at the equation for that. So I have base times height, and let's see, I know the volume is 2010. So I'm going to put that where V shows up, then equals the base. I have to figure out, right? But I know that the radius is 8. So if the radius is 8, my base would be pi times 8 squared, which would be 64 pi. And you know what? I'm just going to, just for the moment, let's leave that as 64 pi. So that's the area of the base, 64 pi. And that's a decimal we can go get in the calculator. But then we're going to multiply by h. So really what I need to do to solve this thing is to get h all by itself. So I'm going to take 2010 and divide it by 64 pi. So 2010 divided by, and then I'm going to use parentheses to make sure I'm dividing by 64 and pi both, and then close my parentheses out. Hit enter, and 9.9969, so that rounds all the way up to 10.0. And so our height would be 10. So let's see, I'll write that right here. So height is 10. And again, what I did was to get height all by itself in this equation, which is the thing that we're after. We're after that height. I'm going to divide the 2010, the total volume, by the base to get h all by itself. And I'm going to switch colors here just because I'm starting to get a lot of red on the page, and I think it's easier to see what I'm doing if I do that. So let's see, we've got the area of a base that we want to find, and it has a volume of 50 and a height of 7.5. So here again, volume equals base height. If we know the volume, that's 50. We know the height is 7.5, and we're after the area of the base, then we just have to divide both sides by 7.5. So take 50 and divide it by 7.5. So 50 divided by 7.5, and I hit enter. Oh, that didn't work out. So let's try that again. We'll clear everything out. 50 divided by 7.5, and hit enter. And 6.6 repeating, or 6 2/3. So our base area would be 6.6 repeating. In this case, it'd be centimeters. And since it's a base area, it'd be centimeters squared. And I should have done that here too. The height would have been inches when I got that answer. Similar deal. I mean, it's the exact same thing we're finding down here. Find the missing dimension on the prism of the cylinder. Well, we've got a volume that they've given us. So I'm going to plug that volume in for V. So 661.5. I don't have a base, but I do have a height. That's 18. So I know my height is 18. I need to figure out the area of the base. So I've used up 2 of the 3 numbers, and I'll get to the other 2 here in a moment. So I'm going to take 661.5 and divide it by 18. So 661.5 divided by 18, and hit enter, and that's 36.75. And that then is the area of the base. Well, the area of the base is a rectangle. So to find the area of the base, I would do length 3.5 times width, so 3.5 times y, which means I'm going to then compute a separate equation, and I'm going to divide both sides of this thing by 3.5, but you already have it in the calculator. So just hit divide by 3.5 and hit enter, and then we're going to get 10.5. So our y dimension is 10.5, and in this case that's centimeters. And the very last one we'll do is this cylinder. So we know our volume for the cylinder again is base height, and we've got our volume, so I'll plug the V in. We've got our height, that's 6. So I'm going to take and divide both sides by 6. So 75.36 divided by 6. So 75.36 divided by 6. 75.36 divided by 6. And that's going to give me 12.56. So 12.56 is equal to the area of the base. The area of the base is a circle. It's got a radius of p, which is what we're after, trying to find. So the 12.56 we know has to equal pi times r squared, which they're calling p, so p squared. So I have to divide by pi and take a square root. So I need to do the square root of 12.56 over pi. So the square root of 12.56 divided by pi, enter, and I've got bunch of 9, so let's call that a 2, and that's it. P is 2.